talk about, today we're going to talk about section 6.2, and which will be the properties of parallelograms and how we can use the special properties and how this ties in with some of the material we've talked about in the past. Okay? Parallelogram, which I've drawn there, parallelogram A, B, C, D. We notice right off the bat that we have opposite sides that are parallel. Okay? So we have to think about that. Now, I want you to think back to items that tie in with parallel lines and a transversal. So if I took line BC and line AD, I really have two transversals. I have the transversal A to B, which can extend out, and I have the transversal D to C. Okay? Remember, we can create with transversals, if I took two parallel lines and a transversal, knowing that these two lines are parallel, we have alternate interior angles that are congruent. Okay? We have same side interior angles that total how many degrees? 180. So these two could total 180. Or I could really look at it this way and say those two total 180. But we have to look and see how the parallelogram is drawn. Okay? We're also going to talk about the diagonals, which give us the properties of a parallelogram. Okay? So go ahead and write that. Okay, now this is important, and I'll cover how we know something's definitely a parallelogram in a minute. But once I know a figure is a parallelogram, there are three things that we can say. Okay? We can say, number one, opposite sides are parallel, or I'm sorry, are congruent. They're already parallel. Okay? So, sorry, once I start recording, it just doesn't write as neatly. So, we know opposite sides are congruent. I already know my handwriting is bad, but now it gets really bad with this. Okay? The second thing that we can know, okay, are consecutive angles. Okay? Well, let me do it this way. Opposite, I'll say opposite angles are congruent. Just write it down. And the diagonals of a parallelogram bisect each other. I'll get it up here. Guys, just write it down. Now, we have to remember on number 3, we've got a key word in there, the word bisect. So that's going to mean something. I'll give you a second to write this down. Okay, we're also going to use the term consecutive angles, and we need to be all on the same base. Consecutive angles of a polygon are angles of a polygon that share a side. So if we think in the terms of a parallelogram, and I'll just draw a really quick parallelogram here. I'm not going to say it's going to be truly accurate, but we'll just say that this is a correctly drawn parallelogram. We're saying that these angles are consecutive. So I can say angle 1 and 2 are consecutive because they are on the same side. We could say angle 2 and 3 are consecutive because they're on the same side. And angle 3 and 4 and back to 4 and 1. Now, what does that mean? If we think back to two parallel lines and a transversal, if I just draw this as two parallel lines and a transversal, and I've got angle 1 and 2, what does that mean? They add up to 180. They're supplementary. Okay? So, we'll talk in a few minutes about how we know this is a parallelogram, but I want to talk about some of the properties of this and what this means. So, I could take whatever the value of angle 1 is and add it to the angle, measurement of angle 2. So I could say the measure of angle 1 plus the measure of angle 2 all has to total 180 degrees. Okay? Those are consecutive angles. So if I were to have a parallelogram that looked like, so if I had a parallelogram like this, and I know it's a parallelogram, I can find the value of x. I can find the value of x knowing that angle URS and angle RST are consecutive angles, so they would total to be what? What would they total to be?
180.
180. So I could write this. So I could write it as 112 plus x equaling 180. Okay? And we've done that several times, so. Now, let's take the first item that we put on our list that we know is true once a figure or a polygon is a parallelogram. And what was the first thing you put down? What was the first thing we know is true about a parallelogram? Opposite sides are congruent. Okay? So if I were to now change this, let me change this. If I just change our parallelogram to look like this, if opposite sides are congruent, how could I set that up mathematically to find the value of x?
3x minus 15 equals 2x.
Right. So if they're congruent, we can set them up equal to each other. So I can write 3x minus 15 equals 2x plus 3. So the second item, and I'm just going to say this again for the recording, is that opposite angles are congruent. So if I were to just say this is 75 and this is x over here, we would know that x equals 75 because these are opposite angles. Okay, these are opposite angles, so x equals 75. Well, that's a special property of a parallelogram. Okay. What was the third item that we knew that was true? The diagonals bisect each other. So let's draw that. Okay, I've gone ahead and drawn.
Just pedal away.
I've gone ahead and drawn that, and I've said that I've gone ahead and drawn the diagonals in there. We've said that the diagonals bisect each other. So when I use the word bisect, what does that mean? Cuts it in half. So if I just concentrate on this diagonal right here, that means this section is congruent to this section, right? And what else do we know about it? section is congruent to this section. They bisect each other.
Oh my god.
Now, if I were to say this, if I gave you values like this, here's an A, here's 2A minus 8, B plus 10, and B plus 2, how can I set that up and solve that? I would pay attention on this one, because if you're not paying attention, I'm not going to answer your questions on this, and neither will Mr. Mitchell. So if you're paying attention, and we'll know who that is, we'll answer your question. If you're yakking away or not writing anything down, good luck. Yep.
Would you like set like B plus 10, B plus 2 equal to 180?
Okay, so you're saying B plus 10 is equal to what?
No, and add those two together and then equal it to 180.
Okay, what do we know about the drawing when I look at this here? This is congruent to this section, right? So mathematically that means what? They're equal. So I could say this. Okay, so I just wrote what you said, which was B plus 10 equals 2A minus 8. So, can I solve that? Why can't we solve it? There's two variables, right? Right. John? Start writing. Okay? Well, let's set the other direction up. Now, I wrote this, A equals B plus 2, because those two segments are congruent to each other. Can I solve that?
Yes.
Okay, I'm hearing no again, because what do we have going on there?
Two variables.
Two variables. Now, think back to last year. What could I do to solve this?
You can solve one variable.
Okay, do I have a variable by itself?
Sure do.
Okay, I have an A that's all by itself. If I don't, I have to manipulate until I do. So all A's equal B plus 2. Okay, if I don't have a variable, I have to transform the equation. Okay, so everywhere I see an A, I'm going to put everything that's in that box. So I can go back to this first equation and substitute everything in for A. So I can rewrite this as B plus 10 equals 2 times the quantity of B plus 2 minus 8. Notice how I just substituted everything in that box for the new value of A. Okay?
And he put parentheses around it to make sure you distribute, not just multiply by 2.
So I can solve that and solve for B because I'm down to one variable. So the first thing I'm going to do is distribute here. I'm going to rewrite everything on this side because I'm not doing anything. So I have B plus 10 equals 2 times B, which is 2B, and 2 times a positive 2 is a positive 4 minus 8. Now, I'm going to run out of room and I'm going to have to move some stuff. I may move this down here. But what would be your next move? Now, I've got all that moved out of the way. So I'm going to come back here. There's a couple different options, but let's just stick with one direction. Ryan, what would you do next?
I got nothing.
You got nothing?
Yeah.
Okay. Billy?
I put the B's in the same side.
You put the B's on the same side? You could do that. I probably would choose to do something else. Mathematically, you're not wrong, okay? I just like to do it consistently, okay? What would you do? Okay? You would, let's concentrate on like things, okay? John, are you sticking with us?
Yeah, well,
Okay.
as much as I can. I don't understand this.
So 2B plus 4 minus 8, you would want to take care of 4 and 8, which would be...
Okay, why could you deal with both of these?
Because they're on the same side.
They're on the same side and they're like terms, right? So I can combine those together. So I can rewrite everything else. And if I have $4 and my wife spends $8, I'm left with what? Not just 4, but -4. Well, I have to admit, in my household, I'm the big spender, my wife is not. But I better make that clear. Now, back to what I think we started with. Billy, I think you were the one that were talking about the b's, correct? We're on opposite sides of the equal sign. So what would you do to solve that?
Minus B, 2B.
Okay, I've got 1b and 2b here. I've got 1b here and 2b here. And we're going to pick the smallest one and I'm going to get rid of it. There's a positive 1b, so I'm going to subtract 1b. And what I do to one side, I do to the other. So these cancel out. So I'm left with positive 10 equals 2b minus 1b, which gives me 1b minus 4. Now I'm going to add 4 to both sides. So b equals 14. Now, I'm not done here. Okay. I've got to solve for a, don't I? So Sierra, how would you do that?
I would put 14 where B is.
Right, now I'm going to substitute my new value of b up here. So I'm going to write this as a equals 14 plus 2, or a equals 16. Now I would have the two values, and I could plug it back in here. I could plug them back into my parallelogram and find what the true values are, okay? And I would find that those are congruent because they bisect. Okay? All right, now, one thing I talked about earlier, and I want to go back, is why is something a parallelogram? Okay? Okay, I'm going to pose a question here, and we're going to talk about why this is the case. Is why are opposite sides of a parallelogram congruent? Okay. Now, if I were to just quickly draw a parallelogram here again. Now, there's a parallelogram. If I were to draw a diagonal in here, let me do that in a different color here. And I'm going to actually extend these out. I want you to concentrate on the fact that this is a parallel line, this is a parallel line, and that's a transversal. Okay? What could we say about angle 1 and angle 2? So if I just quick drew our two parallel lines and a transversal, here's angle 1 and here's angle 2. What can we say about those? They're what? Yes, they are congruent. Why? Alternate interior with parallel lines, right? So we could say angle 1 and 2 are congruent. Well, okay, what does that give me for angle 3 and 4, which would be here? Okay?
They are, but they're with the other lines.
Yep. There we go. So now, I drew that figure there, so that gives me 3 and 4 with the parallel lines. I need to erase this over here. Okay. So 3 and 4, so I could say angle 3 and 4 are also backing up to think about the different, the ways we prove triangles are congruent. Okay? We had side, side, side. We had some different ones, didn't we? What are some other ones that we had? Side, angle, side. Okay, angle, angle, side. Now, if I look at this,
Side.
yep, I said that one.
CPT.
So, oh, now wait a second. You're thinking you're one step ahead. So let's think about this. If I've got angle 3 and 4, remember I need 3 items. I need 3 items to prove the triangles are congruent. So I have this triangle right here, and this triangle right here. Stick with me, John. Okay? So I've got one set of angles, angle 3 and 4. So I'm just going to say that's one set of angles that are congruent. I have another set, angle 1 and 2. Okay? What's another thing that's the same up there?
This line.
Yeah.
This line going between them.
Okay, my diagonal. Now, I didn't label this. If I said A to B over here, I could say A to B is congruent to B to A because of what? Reflexive. So I now have oops, I kind of got this crowded in here. I have a side, right? Now, what's special about that side? What's the location with the angles? It's what? Here's the angles, and here's the side. It's right between them. It's included. So remember, then that gives me angle, side, angle. So I just proved that those two triangles are congruent through angle, side, angle. Now, as you correctly said, by CP/CTC, I can say that all corresponding parts are congruent. So that's why I can say this side is congruent to this side, and this side is congruent to this side. Now, I wanted to explain that to you, okay? You could do this mechanically without ever knowing why, but it's important to draw all that together. Theorem. If 3 or more okay, what this is saying, sticking with us, Roy? Is if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So just write that down, and then I'll show you graphically what that means. Let's draw what this says. It says if 3 or more parallel lines. So let's start off and draw 3 parallel lines here. So let me draw 3 parallel lines.
1, 2, 3. Got it.
Let me do this.
I feel like every one is shorter than the last.
Better? Okay. So I'm close to what I'm doing here. Okay, so I know these are parallel lines. So if I'm looking at the verbiage, it says if 3 or more, so I could have more, but we'll just start with 3. Parallel lines are cut off congruent segments on one transversal. So let me draw a transversal here. There's a transversal. And they cut that into congruent segments. So this segment is congruent to this segment. Okay. Then, any transversal that we draw up there has congruent segments. So, if I know I have 3 parallel lines, or 4, or 5, okay, or more, and I have one transversal that's cut into congruent parts, then any transversal I draw up there will also have congruent parts. So I could say, well, let's just put this transversal over here. I'll make it much different. Okay? So once I know that these two are congruent, then I could say these two are congruent to each other. Okay? Oops. There we go. Now, they're not going to be congruent. I can't say that the green transversal segments are congruent to the red transversal segments, but I can say that the two segments on the red are congruent to each other. And I could put any transversal I want in there. Thought I had that. There we go. So I can put any transversal I want in there. And once I've established the fact that I have congruent parts on a transversal, that means that these are congruent to each other. Now, I can put values to that. If this is 2, what does it make this?
2.
2. Okay? But it doesn't make this also 2. I could say this is 3 and that makes this 3 and so forth. Okay? So having that knowledge, if I read questions, then I can manipulate or figure out values. Okay? Anything you want to add to that? Okay. That'll sum up what we have today. Okay, there's your assignment 1 to 33 odd. For those that are still awake, you can do this.